This is part three of my presentations called Inherent Structure in Artificial Intelligence. So far, we have covered structure in artificial intelligence by looking at the central nervous system of AI, like semiconducting materials, Si and Ge, and dopants like Pb, Ga, and As. We looked at three characteristics of all these elements: molar mass, density, and atomic number. Let us now turn our attention to the skeleton, the skin, and the veins of an AI robot. We begin with our discovery that the basic AI unit is square root PB times P plus B plus 2PB over 2 times P plus B times SI approximately equals phi, which is the golden ratio conjugate. We notice that this has three parts: square root PB times P plus B, 2PB, and 2 times P plus B times SI. We find that the square root of PB times P plus B equals 764.4486 grams squared per mole squared, and 2PB equals 669.5714 grams squared per mole square. And 2 times P plus B times SI equals 2,347.2004 grams squared per mole squared. Since they are in grams squared per mole squared, we take their square roots to find their corresponding elements, and find that the square root of 764.4486 equals 27.64866, which approximately equals aluminum Al, which equals 26.98. And we take the square root of 669.5714 and we find it equals 25.8576, which is approximately equal to Al as well. And now the third one, we take the square root of that, which is the square root of 2,347.2004, which equals 48.4479. This is approximately equal to titanium, Ti. Aluminum and titanium are used to make the skeletons of AI because they are light, strong metals, titanium in particular, or titanium alloyed with aluminum. So these are used for the skeleton of AI. Next, we look at the skin of an AI robot. It would be plastic, of which the simplest plastic is C2H4. How novel it would be if it had the same molar mass as the semiconducting material silicon, Si. Well, it would turn out things are novel because it does. C2H4 equals 2 times 12.01 plus 4 times 1.01 equals 24.02 plus 4.04 equals 28.06, which approximately equals 28.09, which equals the molar mass of silicon Si. But how about the veins of AI? It would be the most commonly used wire, which is copper Cu. I first looked at the amino acid serine, one of the 20 amino acids that are the building blocks of proteins, the units of life compounds, and I invented a way of expressing an amino acid by forming the ratio across its chemical structure to down its chemical structure. So here we see on the left the chemical structure of serine. We add up going down, that's H plus C plus CH2 plus OH. We add going across, that's H3N CCOO. Anyway, so you'll find if you add those up and divide down by across, you get phi, the golden ratio conjugate. This chemical serine here has the chemical formula C3H7NO3. you will find that if you multiply C3H7NO3 by the square root of Pb times P plus B plus 2Pb over 2 times P plus B times Si, that you'll approximately get the metal copper. Okay, we've looked at the brain and central nervous system of AI and the skeleton and skin and veins of AI. We now turn to its vision. To turn on a simple OR gate, you need 0.6 electron volts. 1 electron volt, EV, is 1.6 exponent 10 to the minus 1.6 exponent minus 19 joules. This means the threshold for life is 0.6 times 1.6 exponent minus 19 joules, which equals 9.6 exponent minus 20 joules. We will call it we will call this 9.6 exponent minus 20 joules, we will call it 1 BUE, which will stand for basic unit of energy. The energy E is related to its frequency V by Planck's constant H, which equals 6.626 exponent minus 34 joule seconds. That is, that E equals HV. For an output of 1 BU, basic unit of energy, and a simple diode OR gate, there must be an input of 2 BU. So, given the speed of light, C is 3 exponent 8 meters per second, and wavelength equals C over V, this is a wavelength of 1 micrometer. This happens to be the beginning of the visible spectrum.